Jai Hind everyone, myself Rekha Baghel, Assistant Professor, Computer Science and Engineering Department, Akgec Engineering College, Ghaziabad. So, today we will discuss about the topic Fundamentals of Machine Learning in the AI Context. So, by today, after this session, you will have the understanding of the AI, the foundation of the machine learning, how machine learning helps to create the better AI systems. So, this is the our today's first lecture. So, in this artificial intelligence, so artificial intelligence we can define it is a artificial intelligence also known as the AI, and AI agents are the systems which can use to create the intelligent systems. So, AI systems have the capabilities of the capability of the learning from the environment, reasoning and perceptions from the environment, decision making. AI agents can take the decision by their own. So, the AI agents are used to create the intelligence agents that can act autonomously. For example, the speech recognition, autonomous vehicles, medical diagnosis. So, these are the examples of the AI agents or the AI systems. Why AI needs machine learning? So, basically, before the machine learning, the AI agents are developed by using the simple programming languages. So, these programs, the traditional programming languages or traditional programs are able to solve the simple problems. But when we have the some real world problem or some complex problem, these simple programs are not able to solve that particular problem. So, in this case, the machine learning comes into the picture. So, machine learning is a technique which learns from the experiences, or these machine learning learns from the data. So, we can say the foundation of modern intelligence systems are developed by the machine learning. So, these example of machine learning is like the spam filters continuously learn from new emails instead of relying on the static rules. When we use the simple program for solving some issue, then it depends on the particular set of rules. But if our scenario is developing a spam filters, so as we can see that as new emails are generated day by day. So, these new words are also used in these emails. So, by using, if we developed a machine learning these spam filters, then these machine learning based spam filters continuously learn from the its environment, that is the words in the particular emails consist. So, these machine learning based spam filters can automatically filter out the spams. So, what is the machine learning? So, machine learning is a subset of artificial intelligence. So, these machine learning basically learns the patterns from the historical data, and based on the historical data means it learns from the experience. So, based on the historical data, it learns the patterns, and accordingly it improves its performance with the experience. So, we can say that the no explicit programming required means if we trained our model with some data, then it automatically learn the particular patterns. So, we don't need the explicit programming language. For example, suppose we have an image classification problem. In this image classification problem, the input is the image, and the output we need to predict is a class label. So this is the machine learning, means we give the model a image and the model will predict the label of the image. So key idea is learning from the experience. So whole thing with the machine learning is it learn from the experience. Now next type of learning is deep learning. So deep learning is the specialized version of machine learning. So this deep learning is the specialized form of learning that comes here, means this is a space in which machine learning is a part of artificial intelligence. Then with the help of this machine learning, we can create the specialized form of networks that is known as the neural networks. These neural networks are developed by taking the inspiration from the brain, and this neural network can be used for generating the deep neural networks. So deep neural networks based on are the connection of the different layers, multi-layered architecture of neural networks. So this artificial intelligence is any technique that enables a machine to solve some problem like a human solve that particular problem. Machine learning are the algorithms that allows the computers to learn from the examples. This neural network is the brain inspired machine learning algorithms, and deep learning is the deep neural networks. So the goal of the artificial intelligence is to create the intelligent systems. Machine learning is a data driven learning, and while the this deep learning is a multi-layer neural networks, and there is a hierarchical relationship between the artificial intelligence, machine learning and deep learning. Means first there is AI, after that we will go to ML, machine learning, then we will go to deep learning. So this is the relationship between the AI, ML and DL. Further, we can more explain these artificial intelligence, machine learning and deep learning. So artificial intelligence uses computer science and data to enable problem solving in machines. Machine learning refers to the study of computer systems that learn and adapt automatically from the experience without being explicitly programmed. And deep learning is a type of machine learning technique that layers algorithms and computing units or neurons into the artificial neural network that mimic the human brain. So deep learning, these artificial intelligence give the can solve the problems, real world problems, but artificial intelligence is not capable to solve the very complex problems. After that, machine learning can solve the complex problems, but the results produced by this machine learning is not accurate for the very sensitive is not accurate for the problems which require the very sensitive which are very sensitive to the accuracy. So after that, deep learning comes into the picture. Deep learning uses the very efficient dense networks or deep neural networks. These deep neural networks can provide the results, can provide the accuracy of very accurate level. So these machine learning can be categorized into three types: supervised learning, unsupervised learning and reinforcement learning. So supervised learning, we can say this supervised learning is consists of input and output pairs. what do you mean by this input and output pairs? So input and output pairs are the what type of input we are giving to the model, and output is the label. So what the model will predict the particular label. So for making the model about the particular data, we will first give the training data. First, we will give the training data to the model. So this training data, based on this training data, the model trained itself. So if we are using the supervised learning, means we are giving the input along with its corresponding label. For example, if we are seeing this spam detection means we are giving the email along with spam or not spam. Means we are providing the training data of various emails, and each email is categorized as spam or not spam. So in this case, we are providing the input and output pairs. So model learns the mapping from X tends to Y. Here Y is the output label and X is the input. So the model learn the features of the input, and based on that, these features, the model predict the output. The various types of algorithm that those are used in supervised learning are the linear regression, logistic regression, support vector machine, decision tree, k nearest neighbors. And the applications of the supervised learning are the spam detection, disease classification. Next is unsupervised learning. Unsupervised learning means clustering, means we don't have the labels of the data. We just have the data without the labeling. So no labeled output is there. So what is the purpose of this unsupervised learning? The purpose of unsupervised learning is to make the groups of the data based on their properties. So this unsupervised learning discover the hidden patterns. For example, we can take this example like customer segmentation. Customer segmentation means we have the different customers. Means one customer is of the category of females, okay, and one customer is the category of males. So we have a data with the customer, and these customers have the different choices. Means one customer belongs the section cosmetics, one customer belongs to the category of sports related items, and one customer belongs to the toys. So by using the unsupervised learning based on the hidden patterns of particular customers, we can make the groups of these customers. Means if one customer likes the cosmetics or purchase the cosmetics, then we can say we can make the different group of this customer. And if one customer means if number of customers likes to buy the toys, then we can make the group of or make the cluster of these customers. And this is the next segment. So customer segmentation, image compression, anomaly detection are the applications of this unsupervised learning. And the popular algorithms comes under the unsupervised learning are the k-means clustering, hierarchical clustering, principal component analysis. So principal component analysis is used to minimize the dimensionality. Next section is reinforcement learning. So, reinforcement learning is based on the trial and error mechanism. Means first the agent interact with the environment, and based on the interaction it receives rewards or gets the penalty from the environment. So, if the agent perform good, it receive the reward. If the agent performed poor, then it receive penalty. So, sequential decision making. So, reinforcement is a sequential decision making process. Agents learns by interacting with the environments. The main components of reinforcement learning are agents, environments, action and reward. So, the main goal of the reinforcement learning is to maximize the cumulative reward. So, we receive the reward when the agent performed very good. And the applications of reinforcement learning is robotics, game playing and autonomous systems. So, this is the comparison between the these three types of learning techniques. So, based on the features, we can compare these techniques. First is data labeling. So, supervised learning requires the data labeled data, while unsupervised learning does not need labels data. And this reinforcement learning uses rewards and penalty. The objective of supervised learning is to predict the output. The objective of unsupervised learning is to identify the patterns. The objective of reinforcement learning is to optimize the decision making. The popular algorithms comes under the unsupervised learning. Unsupervised learning is clustering, PCA and autoencoders, and comes under the supervised learning are the regression, SVMs and neural networks. And Q-learning, DQN and policy gradients are the popular reinforcement learning algorithms. The main applications of supervised learning are the healthcare, finance and marketing. Unsupervised learning, cybersecurity, retail and NLP. And the reinforcement learning can be used for robotics, gaming and finance. So, this is the workflow of the machine learning model. So, if we apply the machine learning for solving some real world problem, so this model uses the few phases. So, first phase is data collection. We will collect the data to train our model, and after that pre-processing is done. Data pre-processing is very important for getting the accurate result. If we are providing the inaccurate data or unprocessed data, then our model also learn from the noise. So, data pre-processing is important. After that, model selection. Model selections means which type of model we are going to use. Means whether we are going to use the supervised, unsupervised or reinforcement. We choose the particular model based on our problem. If our problem is a classification problem, then we can go towards supervised models. If our problem is clustering or segmentation type of problem, then we can go towards unsupervised learning models. And if our problem is like a gaming type of problem, then we can go towards reinforcement learning. So, after choosing the model, we next move to the training and validation. So, we can divide our data into two parts, training and testing. For making the learn things from the data, we provide this type of data, training data to the model, and whether our model learns the things perfectly or not, we test our model's learning on this test data. So, training and validation. So, validation is a validation. So, validation basically used, validation data is basically used to hyper tune our model, means we train our data, we check the learning of the our data, but mostly models work very well on the training data, and if and validation data means, validation means we divide our data in training, validation and testing, means 80 ratio 10 ratio 10. Mostly models divide the data in this ratio. You can use 70 15 15, means 70% of your data you can use for training, 15% of data you can use for validation, and 15% of data you can use for testing. So you can just divide your data in these ratios. So when you can use this validation data, means 10% or 15% you can use to hyper tune your model, so that your model can also perform well on the unseen data, that is the test data. So after training the model, we evaluate the performance of our model. After that, if the evaluation of the model is satisfactory, we come to the final model. If the evaluation is not satisfactory, then we can go back towards we refine the data pre-processing steps, we refine the model selection steps, and further execute these steps again. So we can categorize these data into 3 categories. First is structured data, second one is unstructured data, and third one is semi-structured data. So these structured data are represented by using the tables and spreadsheets. Unstructured data comes into the form of images, text or audio. Semi-structured data comes in the form of JSON files or XML files. So based on this data, the model learns the features from the data. These features, if we talk about the tables, then the particular columns are known as the features of the data. So these features affects the performance of the model. If we have a set of good features, then our model perform exceptionally well. So feature engineering is very important to improve the accuracy of the model. If we are doing the machine learning, then the handcrafted features are used in machine learning, but when we are doing in deep learning, then these feature engineering is automatically done by the deep learning models. So normalization and selection are important. Which type of features we are selecting, it affects the performance of the model. So normalization and feature selection is important. So quality of data directly affects the model's performance. Model evaluation, we can evaluate if our model is of classification type, then we can evaluate our model's performance by using the accuracy, precision and recall, and F1 score. These are the evaluation measures, performance measures, and if our task is for the regression, then error matrix can be used, means we can use MSE. Challenges in machine learning. The main challenge of the machine learning is that the data is very limited, and when we have the data is not balanced of type, means if for classification problems we need the data in which the each class have the equal amount of data. If we learn our model, if we provide the, suppose these are the three classes, class 1, class 2 and class 3. If we provide the examples of class 1 of 100, class 2 is of 10 and class 3 of 500, that means our models will learn this class 3 very much good in comparison to class 2 and class 3. The performance of our model on class 2 will be very poor, as we give the very less number of examples of class 2 to our model. So our model perform very weak on the instances of class 2. So this is the imbalanced data. So overfitting and underfitting. Overfitting means if we provide very much training data to our model, it will overfit on the testing data. It will try to classify each and every instance. So this is the overfitting. Underfitting means we provide very less number of training data to our model, then our model will not classify the instances very will not classify our models appropriately. So this is a underfitting. Bias and fairness issue, lack of explainability. So these are the few challenges of the machine learning. Ethical and explainable AI. So the AI we used must be fair and unbiased, means the models we are using must be fair and unbiased, means it will not be biased towards any class. Data privacy and security, transparency and trust, need for explainable AI. So this is the ethical AI. Ethical AI must be transparent. It should provide the fairness. Ethical AI provides the accountability, means if a particular AI model provide the solution to some problem, it must be AI must be accountable to that particular solution. So accountability will be there. Privacy, it will not breach the privacy of some person or some organization. Building trust. So ethical AI must be build trust, means if it provides this solution to the problem, then the trust factor must be there, means it will not provide the false solution. Preventing harm. So ethical AI encourages the preventing harm, and so these are the some ethical concepts of the AI. These are the applications of machine learning. Machine learning can be used in healthcare sector, finance and banking, e-commerce and retail, transportation and mobility, entertainment and media, manufacturing, agriculture and education. These are the very few areas in which the AI can be used. In today's era, AI can be used, or machine learning can be used in almost each and every sector. So in today's lecture, we get an idea what is artificial intelligence, how machine learning helps in artificial intelligence to develop the solution of the complex problems, and what are the different paradigms used to solve the different problems, what are the supervised learning, unsupervised learning, reinforcement learning, and what is the workflow of the machine learning models, what data quality, why data quality is crucial, ethics and evaluation, how ethics and evaluation matters. So these are the this is the all about the machine learning in AI context. Thank you.